Hello everyone, this is Priyanka K studying at Venkateshwara College of Engineering. Today in this video we'll be looking into deadlocks. Firstly, we'll see what is deadlocks. A process requests resources. If the resources are not available at that time, the process enters a waiting state. Sometimes a waiting process is never again able to change state because the resources it has requested are held by another waiting process. This situation is called deadlock. System model of deadlocks. A system consists of finite number of resources to be distributed among a number of competing processes. The resources are partitioned into several types, each consisting of some number of identical instances. Memory space, CPU cycles, files, and input output devices are examples of resource types. A process must request a resource before using it and must release the resource after using it. A process may request as many resources as it requires carrying out its designated task. The number of resources requested may not exceed the total number of resources available in the system. Under the normal mode of operation, a process may utilize a resource in only the following sequence: request, use, and release. In request, the process requests the resource. If the request cannot be granted immediately, then the requesting process must wait until it can acquire the resource. Use. In the use process can operate on the resource. The process releases the resource in the release sequence. A set of process is in the deadlocked state when every process in the set is waiting for an event that can be caused only by another process in the set. The events with which we are mainly concerned here are resource and release. The resources may be either physical resource or logical resource. To illustrate a deadlock state, consider a system with three CDRW drives. Suppose each of three processes hold only one of these are CDRW drives. If each process now requests another drive, that and the three process will be in the deadlock state. Each is waiting for the event CDRW is released, which can be caused only by one of the other waiting process. This example illustrates a deadlock involving the same resource type. Deadlock may also involve different resource type. For example, consider a system with one printer and one DVD drive. Suppose the process PI is holding the DVD and the process PJ is holding the printer. If PI requests the printer and PJ requests the DVD, a deadlock occurs. Next, we'll move on to deadlock categorization. What are the categorization conditions? A deadlock situation can arise if the following four conditions hold simultaneously in a system. First is mutual exclusion, hold and wait, no preemption, circular wait. In mutual exclusion, at least one resource must be held in the non shareable mode. That is, only one process at a time can use the resource. If another process requests the resource, the requesting process must be delayed until the resource has been released. In hold and wait, a process must be holding at least one resource and waiting to acquire additional resources that are currently being held by other processes. In non-preemption, resources cannot be preempted. That a resource can be released only voluntarily by the process holding it after the process has completed its task. In circular wait, a set of P0, P1 into Pn of waiting process must exist such that Po is waiting for the resource held by P1, P1 is waiting for the resource held by P2, to Pn minus 1 is waiting for the resource held by Pn, and Pn is the waiting for the resource held by P0. Next, we'll go to methods of handling deadlocks. The deadlock problem can be handled in one of three ways. Use a protocol to prevent or avoid deadlocks, ensuring that the system will never enter a deadlock state. Allow the system to enter a deadlock state, detect it, and recover. Ignore the problem altogether and pretend that deadlocks never occurred in the system. To ensure that deadlocks never occur, the system can use either deadlock prevention or the deadlock avoidance scheme. Deadlock prevention provides a set of methods for ensuring that at least one of the necessary conditions cannot hold. These methods can prevent deadlocks by constraining how requests for resources can be made. Deadlock avoidance requires that the operating system be given in the additional information concerning which resource of a process will request and used during its lifetime. Deadlock prevention. Deadlock can be prevented by ensuring at least of by these four necessary conditions cannot hold: mutual exclusion, hold, and wait. In mutual exclusion condition must hold for non-shareable resources. Shareable resources do not require mutually exclusive access and thus cannot be involved in deadlock. In hold and wait, to ensure that the hold and wait condition never occurs in the system, then guarantee that whenever a process requests a resource, it does not hold any other resources. Deadlock avoidance. To avoid deadlocks, an additional information is required about how resources can be requested with the knowledge of the complete sequence of requests and releases for each process. The system can decide for each request whether or not the process should wait in order to avoid possible future deadlock. Safe state as in a system can allocate resources to each process up to its maximum in some order and still avoid a deadlock. Safe sequence. A sequence of process less than P1, P2 to Pn is a safe sequence for the current allocation state. If for each pi the resource request, the pi can still make can be satisfied by the currently available resources plus the resources held by all pj. Deadlock detection. If a system does not employ either a deadlock prevention or a deadlock avoidance algorithm, then deadlock situation may occur in this environment. The system may provide an algorithm that examines the state of the system to determine whether a deadlock has occurred. Recovery from deadlock. The system recovers from the deadlock automatically. There are two options for breaking a deadlock. One is simply to abort one or more processes to break the circular wait. The other is to preempt some resources from one or more of the deadlocked process.